Hello my dear students, welcome back to NEET WORLD. So today in this session we will be beginning the organic chemistry. Okay, so in all previous classes we were discussed about inorganic compounds. Example, inorganic compounds and inorganic chemistry, I can say something like periodic table we discussed and its classification we discussed right now, and the properties of elements, that is what periodic properties we have discussed, like atomic radius, ionic size, as well as ionization energy, electron gain enthalpy, electron negativity, all these things we discussed, right? And previous to that we were discussing about very basic thing like atoms, molecules, molecular weight, molar mass and mole concept right now. So that mole concept topic comes under physical chemistry part, where it includes numericals, like solving the numericals, like what is the quantity of ammonia product formed, that thing we discussed in stoichiometric calculations, right? Yeah, like limiting reagent, excess reagent, all these things were discussed, right? Now here, if you haven't watched those sessions, I suggest you to watch. Okay, even if you are new to this channel or this session, you watch this session completely so that you will get some clarity on organic compounds and organic chemistry first. Okay, so whenever you have time, you watch the previous sessions also. Okay, let's begin the session from very basic. Okay, so the first thing here is chemical compounds. Like when you are considering any chemical compounds, what I am saying, any chemical compounds if you consider, so these can be classified as two ways. One is organic compounds and other one is inorganic compounds. So how we are saying a compound is organic or inorganic? Okay, it is very simple. So inorganic, the name itself saying that comes from non-living sources. So where this comes, compounds comes from, inorganic compounds comes from non-living sources. Okay, non-living sources. Okay, whereas organic compound generally considered as comes from, these are considered as, they can be originated from living things only, living organisms or living things you can mention. Okay, living things like from animals, plants, like this. Okay, so this is what the basic fundamental classification of the given compound as organic or inorganic. Okay, for example, you have studied about ores, minerals, right now. So ores, minerals, all these things comes under inorganic compounds. Why they comes under inorganic? Because they are extracting from the earth crust, which is a non-living source now. Okay, so it does not have any, does it have anything like plants or animals? See, they have some life right now. So if we are extracting them from any living sources, then we can say it as organic. For example, extraction of something like let us consider anything, any source you can take, like amino acids you can consider, or proteins you can consider. All these things are considered as what? Organic compounds only. Okay, right. So this is how the basic classification. What is the basic classification? I told you, if the compounds are extracted from non-living sources, then that can be considered as inorganic compounds. Like all minerals you can say, are minerals, ores are best examples to be understood. Okay, and then next, when it comes to organic compounds, they can be originated from where? Living things. Okay, something like proteins, amino acids, biomolecules are some examples of organic compounds. Okay, hope up to here it is clear. Okay, so this is how the name organic came. So organic says, organic ante enti? So organic ante natural ga living things lo nundi వచ్చేదాన్ని, living things are plants, animals నుంచి వచ్చేదాన్ని మనం organic compound అనుకున్నాం. Basic understanding ఇది. Okay, and tarvata scientists were discovered, they did some research and they found that organic compounds can also prepared in the laboratory, not just from a living source. Okay, therefore the first organic compound prepared is urea in the synthetical way, that is in the laboratory. Okay, so what is the first compound prepared in the laboratory? First organic compound is urea. Okay, so what is the first organic compound? Urea. What is the formula of urea? So CONH2NH2. Okay, this is a formula of urea by Wohler. Who is a person synthesized this? Wohler. Okay, Wohler, you can remember. So urea is the first organic compound synthesized in the laboratory. Okay, remember. So previously what they have considered, organic compounds అనేవి మనం synthetic laboratory synthesize చేయలేం, they just comes from, they just originate or they just extracted from living things like plants and animals. We cannot prepare them synthetically in the laboratories. Okay, this is what their fundamental consideration. But later on what happened with the scientist approaches, we got an organic compound that is prepared in the laboratory. Okay, that is the first compound here, urea. So like this the organic compounds definition were got changed. Okay, finally what you can say is the carbon, the organic compounds are the compounds of carbon and hydrogen and some other heteroatoms. What do we mean by heteroatoms? Something like oxygen, nitrogen, halogens, sulfur, etc. Okay, but mostly what they do have, the organic compounds of carbon can be considered as organic compounds here, carbon, hydrogen. Okay, if in the given organic compound only carbon, hydrogen is there, means you should call it as hydrocarbon. What is that? Hydrocarbon. Along with carbon, hydrogen, if oxygen or any other nitrogen, halogens are present, then you can consider them as organic compounds with heteroatom. Okay, right. Now tell me what are the examples we have. So here anything like methane, like carbon, hydrogen is only there, no? So you can say this is also a hydrocarbon, which is an organic compound. Okay, like this you can take anything like benzene. Okay, all these are examples for what? Organic compounds. Okay, like amino acids, just now I told you. Okay, these are some examples of organic compounds. Okay, and inorganic I have given the definition, basic definition, that comes from non-living sources. Okay, that is fine, right? Okay guys, if you have any confusion please let me know. ఏదైనా కన్ఫ్యూజన్ ఉంటే చెప్పండి అమ్మా. Okay, if no confusion, let us move forward here. So you can say organic compound definition as organic chemistry is a study of compounds primarily made up of carbon and hydrogen, possibly some other elements such as oxygen, nitrogen, sulfur and halogens. This is what we have discussed organic compounds means. So organic chemistry means the study of that organic compounds. Now what do we mean by organic compounds again? So organic compounds are nothing but which are made up of, primarily made up of carbon and hydrogen, and sometimes they may also have some heteroatoms like oxygen, nitrogen, sulfur, etc. Okay, now carbon, now we need to understand the chemistry of carbon in order to get some better clarity on this organic compounds and their chemistry. So carbon has tetravalency. What do we mean by tetravalency? If you observe, carbon atomic number is 6, so you are writing it as 1s2, 2s2, 2p2. Right now this is what the electronic configuration. Now how many valence electrons are there? 4 valence electrons are there. So write them like this. Okay, so represent these electrons here like this we have. Okay, so now how many valency orbitals we have? 4 orbitals we have. Each orbital can accommodate 2 electrons. Like that, valency orbitals required 4 electrons. Now still 4 only we have, still 4 more electrons are required. So 4 more electrons are required now. So in order to gain that 4 electrons, it can mutually forms a covalent bond with other elements like this, and it can make 4 bonds because each bond contains 1 electron from carbon atom, the other electron from that bonded atom. Like that, it can make 4 bonds like this. Okay, so this is what the tetravalency of carbon. So what is the maximum valency of carbon? 4. Okay, remember this. Carbon exhibit valency 4 in its compound. This is called tetravalency of carbon. I hope up to here it is clear. Right, let us move forward with little more discussion. See, now carbon has different allotropes. So what I am saying, carbon has different allotropes. Now what are the allotropes we have for carbon? Diamond, graphite and fullerenes. What are those? Diamond, graphite and fullerene. Okay. So now in diamond, each carbon is surrounded by 4 other carbons, 4 other atoms. Okay. Particularly in diamond, each carbon is surrounded by 4 other carbons like this. So it means if you consider the central carbon, like one of the carbon, how many bonds it is having? 1, 2, 3, 4. So 4 bonds is there now. So all 4 bonds are single bonds only, sigma bonds only now. You can say the hybridization of this carbon as sp3. So how many bonds are there? 4. So 4 bonds means s, p1, p2, p3. So sp3, 3 p orbitals are there now. So one s, remaining 3 are p. So sp3 hybridization you can say for the carbon in diamond structure. Okay. So each carbon bonded to 4 other in a rigid 3-dimensional structure that gives it to be hard natural substance. What is the hardest natural substance that is known? Diamond, remember. Okay. When it comes to graphite, so graphite, each carbon is again attached to other carbon. Okay, like this. Let me make the structure like this. Okay, it will be in the ring forms like this, cyclohexagons. Okay, so like this it will be having. Like this, if you observe, this kind of rings will be there, condensed 6-member rings are there. Okay, and one layer will be like this, one layer is made up of these rings, again second layer will be there below it, again one more layer it will be there. So like that, layer strike structures will be there. So between 2 layers there will be some gap. Okay. Now what happens is that one layer slides over the other, one layer slides over the other. That's why when you touch graphite, graphite is nothing but that pencil lid, we are using a pencil. So that lid, whatever you are seeing, black color lid, that is nothing but graphite only. So if you touch that graphite like this, so how you will feel? You will feel like greasy nature, right? Greasy, slippery nature. Why? Because one layer will be on the other layer, so they will slide over each other. That's why when you touch it, you will feel greasy. That slippery nature is because of this layer sliding nature. Okay, remember this. So now what is the reason for them? There is a van der Waals force between these 2 layers. Remember that. Okay. Next, one more thing here is these. In graphite, each carbon, if you observe, let us say this is a carbon, this is another carbon, like that if you observe, so there is 1 bond, 2, 3. So 3 are sigma bonds and there is a multiple like pi bond here if you observe, right? So this is pi bond. So a carbon with 3 sigma bonds, right now 3 sigma bonds and 1 pi bond. So do not consider pi bonds here, only how many sigma bonds we are seeing? 3 now. So you can say this carbon hybridization as sp2. What is the hybridization of carbon here? sp2 in the graphite. Okay, in diamond it is sp3. Hope it is clear. About fullerenes we will discuss later. So in your class 10th, if you observe, there is something called fullerene buckyballs. Buckminster fullerene structure you might be seeing in the class 10th carbon and its compounds chapter right now. So those are nothing but C60 fullerenes, which is nothing but an allotrope of carbon only. Okay, these are the 3 allotropes. I hope you are aware of this, right? Let us see. I just wanted to go with your 10th as well as 11th chapter, I mean concepts, so that you will feel easy to understand. That's why I am discussing about the basics of class 10th. See, these things already you studied in class 10th, right? So now what you need to do is just go through that pages, like carbon and its compounds, you open the book and go through that pages and you can have a look into it, so that you will get some clarity. Okay, right. Now here an allotrope of carbon which is hardest. What is the hardest substance we discussed? Diamond, right? So that is your answer. An allotrope used as a lubricant. Just now I told you that graphite has slippery nature. So due to its slippery nature, graphite can be used as a lubricant at higher temperature, because these normal oils, greases won't tolerate that much high temperature. therefore we will be using graphite as a lubricant. Okay, so third option will be perfect for the discussion. Next. Okay, now what about this catenation property? Catenation property is nothing but self linkage properties like this. See, if there is a carbon atoms like this, now what happens, a carbon can have ability to form self linkages with itself. See, 1 carbon, 2 carbon, 3 carbon, 4 carbon, like that if we arrange, so they have self linkage properties like this. It means they can make a very large like number of sizes. Okay, like this. See, this is a unique ability of carbon to form long chains, rings by bonding with other carbon atoms. So this property rise to give alkanes, alkenes and alkynes. Okay, so and aromatic rings also. Okay, so carbon has a unique ability. What is that ability here? Catenation property. What do we mean by catenation property? The self linkage property. That means carbon has ability to link with other carbon atoms. Okay, so that it will make a bigger chains or close rings. This results to give us organic compounds like alkanes, alkenes, alkynes and aromatic hydrocarbons like cyclic rings. Okay, so I hope you got what do we mean by catenation property. Okay, right. Let us slowly enter into the topics. Now what I told you, due to the catenation property, carbon can make some compounds, some called as alkenes, alkenes and alkynes. No? So now alkanes means something like this. What is the valency of a carbon we discussed? 3, 4 right now. So now 3 valencies are satisfied by hydrogen and carbon is combining with one more carbon here. Again this carbon is attached with one more carbon here. Like this the chain keep on going on, you can consider, otherwise you can end up here. Okay, now try to satisfy the valencies of carbons here. So 3 plus 1, 4, this is satisfied. Here it is also satisfied. Now 2 bonds only there means 2 more required, put hydrogens 2. Here also 2. So how many carbons in the chain? 4 carbons. Now you can say this as butane. What you can say? Butane. Butane is an example of alkane. What I am saying? It is an example of alkane. See, you are saying the name as alkane. So this ane indicates the given compound does not have any pi bonds. It is a straight chain with sigma bonds only here. See, it's a compound with only sigma bonds, right? So you can say it as alkane. So what do we mean by alk here? How many carbons are there? 1, 2, 3, 4 now. So in the place of alk you can write but. 4 carbons are now there now. So but. So it's an alkane. So ane, butane, sigma bonds only. Okay. So like this we have alkanes. Next thing I am writing, you just see with the 4 carbons. With the 4 carbons, what I am making. So like this, if I make a structure, so what happens here, I can insert a pi bond and here it can be CH3, CH2, CH. Okay. So now what you are seeing here, there is a pi bond and a sigma bond, right? So due to this reason, we can say this compound as alkene. What I can say? Alkene. So in alkenes, what is the thing that we are going to have? At least one pi bond should be there. What I am saying? There should be at least one pi bond. Okay. See, we have a pi bond over here. So due to this reason, the carbons here will be having, these 2 carbons will be having sp2 hybridization. What is the hybridization? sp2. Why? Because these 2 hydrogens, a sigma bond, one more sigma bond here. Okay. So 3 sigma bonds means sp2, 1 pi bond as it is. So sp2, alkenes have at least 1 pi bond, you can remember, and hybridization of that carbon should be sp2. Okay. Here in alkanes, all carbons should be sp3 only. Okay. If there is at least 1 carbon with sp2 hybridization or 2 carbons with sp2 hybridization here with 1 pi bond, you can say alkene. Okay. And one more type of compound is there, those are called alkynes. What I am saying? Alkynes. So there should be at least 1 CC triple bond in the given compound. How many triple bonds? I mean 1 triple bond like this. Okay. You can say this is the very smallest alkyne possible. So the smallest alkyne, if you observe, carbon having 1 hydrogen, this is sigma bond. So out of these multiple bonds, 1 is considered to be sigma, remaining 2s are pi bonds. Remaining 2 are what? pi bonds. So 2 sigma bonds means this is sp, and here also it is also sp. Like this you can understand. Okay, once again, so in alkyne we have sp carbons, 2 sp carbons, you can understand. Okay, now from this what you need to know is, if there is at least one pi bond in the given compound, once again, if there is at least one pi bond in the given compound, once again, if there is at least one pi bond in the given compound, you can call them as unsaturated compounds. What you should call? Unsaturated compounds. So these two are what? Unsaturated compound. These two are what? Unsaturated compounds. Okay, so they have one pi bond here and 2 pi bonds here. Each carbon is sp hybridized, here it is sp2 hybridized, then you can say them as unsaturated compounds. Okay, if there is no pi bonds in that, all carbons are sp3 hybridized, you can call these as saturated. What this is? Saturated. So I told you two names now, one is saturated, other one is unsaturated. So saturated, unsaturated, just read these lines once. Saturated means they have only sigma bonds between the carbon atoms. What are the examples here? I can say alkanes, cycloalkanes are the best example for saturated compounds. Next, unsaturated compounds means compounds they contain at least one pi bond. See here, contain one or more double bonds, triple bonds. Examples, alkenes and alkynes. Hope the discussion is clear. Now identify the given compound is saturated or unsaturated. A, B, C. So just identify and tell me which of them are saturated, which is unsaturated out of this A, B, C options. Yeah, who are watching, feel free to express your answers in the comment box. Whoever is watching, please respond based on your understanding. Okay, right. Next thing is, next we'll add few more questions here, few more examples. See, if you have seen the compound, I have made them like a straight chains like this, open chains. This is like a closed ring right now. So you can say these compounds are cyclic compounds. What they are? Cyclic. These are open structures. These are cyclic forms. Okay, like how many carbons you are seeing? 1, 2, 3, 4, 5 now. So you can simply call it a cyclopentane. Okay, do we have any pi bond in this? No pi bond now. All of them are only single bonds only. So CC single bond is there, means alkane now with 5 carbons. So pentane, cyclic structure, so cyclopentane. Like that you need to write the name. So now tell me A, B, C, D. Out of them, which are the following are saturated and unsaturated? Okay, so based on your understanding, please mention your answer in the comment box. Please give me your answer in the comment box. What will be your answer for this? Okay, right. Next, let's move forward. Okay, now we have discussed about alkenes and alkynes now. So now let us look into the simplest alkane that is possible here. Okay, or alkenes and alkynes also. See, there should be carbon with sp3 hybridization, and let us make it with 2 carbons. Here I am writing. So with 2 carbons, CC bond is there, and along with that hydrogen should be there. How many should be there? So there should be only one CC bond, sigma bond only, and the remaining valencies of carbon should be balanced by hydrogens like this. Okay, now write them in the generalized form like C2H6 we got. Okay, and with 2 carbons I am making an alkene. So alkene, there should be one pi bond, balance the remaining valencies with hydrogen on each carbon. So we get this formula. So here formula is C2H4 we got. Okay, now one more thing, let us make an alkyne also, alkyne. So carbon, carbon, make it triple bond, Now balance the remaining valency of carbon by using hydrogen. The formula becoming C2H2. So I told you this is alkane, this is alkene, this is alkyne, if you have observed. Okay, right. So now if you write any of the alkane, that should satisfy a formula something like this. Say I am generalizing it like this. C, how many carbons are there? 2. So Cn. Okay, let me change the color of the pen. Okay, so CnH2n plus 2. So it means what is the n value here? We have 2. H is 6 na, 6 hydrogens are there na, so 2 2s are 4 plus 2 6. It means what is the general formula of alkanes? CnH2n plus 2. So that is the general formula of alkanes. Similarly, when you look at these alkanes, satisfy this kind of formula CnH2n, that's it. C2 2s are 4, C2H4. Okay, when it comes to alkynes, it is satisfying a formula like CnH2n minus 2. So how many carbons are there? 2 carbons. So C2H. So H also like 2 to the 4 minus 2. So minus 2. So 2 hydrogens. So what are the general formulas we have? CnH2n plus 2 for alkane, CnH2n for alkene, CnH2n minus 2 for alkynes. Okay, right. So up to here it is clear now. Now let us move one more type of compounds. Those are aromatic hydrocarbons. What they are? Aromatic hydrocarbons. So these are special type of organic compounds which comes under unsaturated compounds only. What I am saying? Which comes under unsaturated compounds only. Whenever you hear the word aromatic, you need to know one thing. Whenever you hear the word aromatic, the compound must be cyclic first. What I am saying? Compound must be cyclic, something like this. Okay, compound must be cyclic. Okay, it should be in the cyclic form. Okay, and compound must be unsaturated. What I am saying? Whenever you hear the word aromatic, there should be cyclic, there should be unsaturation. Unsaturation means what? Here I am writing, see, pi bond. If at least one pi bond is there in the given compound, you can say it as unsaturated. So compound should be cyclic and unsaturated. Okay, there are other conditions to be satisfied to become an aromatic compound, but as of now what I am saying, just for identification purpose, what you need to know, always aromatic compounds are cyclic. Okay, this is the first thing, and there should be at least one pi bond in the given structure. Okay, and the remaining and the best rules are the proper rules we will discuss separately when I am explaining about aromaticity, but as of now you remember like this. Okay, so what is the compound name here that I have written? So this is called benzene. So benzene is best example for aromatic compounds. Okay, compounds with benzene rings like benzene, toluene are examples of aromatic hydrocarbons. Okay, now what I told you, all aromatic hydrocarbons are cyclic, all aromatic hydrocarbons are unsaturated. Okay, remember these two words. Unsaturated means what? The carbons in the given compound must be containing at least one pi bond, okay, right. Like, let us move forward. Yeah, so now for example here I am writing two compounds, you just observe, CH3 CH2 OH, CH2 CH3 CH2 NH2, and CH3 CH2 next let us write Cl. Okay, so I have made three compounds here, ABC compounds. If you have observed, this fragment is same here, this fragment is same. That fragment whatever I highlighted, this thing is called hydrocarbon chain. How many carbons are there? 2 carbons, C2. How many hydrogens are there? H5. So this group is called alkyl group, particularly 2 carbons are there, means you should say it as ethyl group. What is that? Ethyl group. Okay, so now our discussion is not about this but about these things, extra parts. Okay, so now the property of a given organic compound is characterized or is decided by the group which is attached with our alkyl chain. Once again, the characteristic property of a given organic compound decided by a group, an atom or a group of atom. That atom or group of atoms are called functional group. What this functional group will do? A functional group decides the characteristic property of a given organic compound. Once again, what this functional group will do? That decides characteristic property, whether the compound should be acidic or it should be basic or it should have some other volatile nature, non-volatile, all will be decided by what? This functional group. Okay, so now once again read the statement. Functional groups define the chemical reactivity of given organic molecules. Okay, now what are the functional groups? Here I have mentioned OH group, that we are using it as a sanitizer, na, ethyl alcohol or isopropyl alcohol in the sanitizer bottle. During COVID time we have used it a lot, right? And also that drinking alcohols are there, na, whiskey, all these things like beer, whiskey, all these things, they also contains what? Alcohol, this one only, right? But with different concentrations. Okay, so now it has some other properties, like there we have used to act like against the germs. Okay, so now when it comes to this amine, ethyl amine, what is the name of this compound? Ethyl amine. This is ethyl alcohol, this is ethyl amine. These are the common names. So these are the common names. Okay, so now this ethyl amine group is there now. That amine group NH2 decide what type of character this compound should show. That is what the importance of functional group. Okay, remember. So now we have different functional groups like this. One is alcohol, I told you. Other one is amine, I told you. Like this we have something like aldehydes, ketones, carboxylic acids, halides. So these kind of functional groups are there which are very important. Okay, so in order to understand the chemistry, the chemical reactions of organic compounds, you must aware of these functional groups first. Okay, there are other functional groups I will show you, but for basic understanding you can write this. Okay, right. Okay, so now look at this, what I am making. I have written a formula here. C 4H10, what I have written? C4H10 I have written. With this formula, see what I am making, like this I have made a chain. So H3s, just balance using hydrogen, just balance the valency using hydrogens. Okay, like this I have made. One more structure I am writing with the 3 carbons only. Have you observed? Both of them have same chemical formula. How many hydrogens? 3 plus 2, 5 plus 5. So 10 hydrogens, 4 carbons. Here also 4 carbons, 3, 9 plus 1, 10 hydrogens. So both are having same formula now. So it means this compound A and compound B are called isomers. What they are called? Isomers. Okay. Now what is the basic definition of isomers? Isomers are the compounds having same molecular formula. What they are? Isomers have same molecular formula, but if they differ in the structure, you can call it as structural isomer. If they differ in the spatial arrangement, you can say stereoisomers. Okay, once again read the statement. Isomerism. Isomers are compounds with the same molecular formula, but different structures or spatial arrangement of atoms are different. Then you can say them as isomers. What they are? Isomers. Okay guys, is this clear? What do we mean by isomers? Once again, see, I have taken a formula. With this chemical formula, I can draw a structure like this or I can draw a structure like this. Okay, both structures are possible only now. Both of them are correct, satisfying their valency now. So A and B, this structure and this structure are called isomers. Okay, now how do they differ? See, in the straight chain, the longest chain, how many carbons are there? 4 carbons are there. But here, the straight chain, the longest carbon chain here having only 3. So they differ in the structure of the compounds. Isomers which have same molecular formula, but they are different in the structure. then you can call them as structural isomers. What they are? Structural isomer. So these two are examples for what? Structural isomers. Hope it is clear, right? Now some compounds. Let us write one more. Same C4 H10 O. Okay, like this I am writing. So now what are the structures possible here? You just write some structures, not all possible. If you write whatever strikes into your mind. Let us understand the concept first. Okay, 4 carbons are there now. With 4 carbons I am making a chain like this. Okay, done. Next, here you won't understand it in this way if you are not clear with this. So let us make it like this. Okay, now look how many hydrogens carbons are there? 1, 2, 3, 4. 4 over carbons. Hydrogens 3 plus 2 5 plus 2 7 plus 2 9. Right now 9. So one more is there, I am writing over here. Okay, right. With the same formula, so what I have made here, just look at this A and B. So A, B are having same chemical formula, yes, same chemical formula, but there the position of this hydroxy group, this alcoholic group is different. So in the first case it is at the first carbon, in the second case it is at the second carbon, right? So the position of OH group is differ. So both of them are having same chemical formula, but they differ in their structure. How particularly? The position of hydroxy group is different. So you can say them as structural isomers, particularly they differ in the position now. So you can say positional isomer. What they are? Positional isomer. Like this, we have discussed about organic, inorganic compounds and its classification, basic difference. The next, understanding about the basic definition of organic chemistry. The next, the compounds that are involved in organic chemistry, okay, and little bit about functional groups, and the next about isomers. Right now, yeah, slowly I will make you to do some chemical reactions also in the upcoming sessions, but as of now you go with this again, okay, be thorough with this and do practice some basic approaches towards organic chemistry, and we need to look into IUPAC nomenclature also. Like I have written 2 structures. Do they both have same chemical name, or the chemical structure is different? So if chemical structure is different, we should give a different name, right now. So for giving the names for the organic compounds, we have set of rules, okay, which are given by IUPAC, okay, IUPAC, you can say IUPAC, okay. We need to follow them to give the name for this kind of compounds. For example, I can call the first compound as 1-butanol. What I am saying? 1-butanol, whereas second compound as a 2-butanol. So they have some little difference, 1 and 2 positions, right? So like this, there are some set of rules to be followed while writing the names that we are going to discuss in the upcoming session. So yeah, stay connected with this NEET World channel. So thanks for watching. Share this content with your friends who are preparing for NEET, JEE or EPSET, who have completed their class 10th, moving for class 11th particularly, or class 12th. Yeah. So thanks for watching. Stay connected. Thank you.